About to start. Please get seated. Hi, everybody. Good morning and a warm welcome to this yet another Baltic Breakfast. And today we're going to talk about sewage sludge, this issue that has been on the debate for so many years. It's considered, of course, both a resource that's really valuable because of its content of phosphorus, but it's also a problem. You know, it's presently filled with contaminants. So we will discuss this together with two researchers, as always. We who organize these Baltic Breakfasts, we come from Stockholm University Baltic Sea Center. And my name is Gun Rudqvist, and I will be trying to lead you through this morning's presentation. And for all of you, please make sure you pose lots of questions, because you'll have lots of times at the end to pose questions to the researchers. And you can also do that online, of course. And it's either by sending us an email, ostersjocentrum.su.se, or use the Slido code 22102, and I'll try to remember to repeat the code later on. And if there isn't enough time to pose all these questions or either to answer them, we will try to gather them afterwards and present some answers also on our webpage. All right, today's topic, sewage sludge, as I started saying, both the resource and a problem. And it's been debated for a long time, you know, what to do. How can we use this? How can we get hold of phosphorus, the finite resource that we need to put into circulation and bring back to agriculture? And how can we do that without risking more contaminants in our soils and, of course, eventually in our waters? And has this an effect on the Baltic Sea? So let's get started right away. And first, I will introduce our speakers. And it is Arno Rosmarin, who is a senior research fellow at the Stockholm Environment Institute. And thereafter, we have Gert Cornelis, who's a researcher at the Department of Soil and Environment at the Swedish Agricultural University here in Uppsala. But first, I'll give the floor to you, Arno, and you will walk us through a bit more about the phosphorus issues. Please, Arno.
Okay. I think this mic works, yes. So good morning to you all. It's nice to see you, some familiar faces. I'm going to be talking for 12 minutes, it's supposed to be. And I guess I'm going to have to look at this screen because things are just too small on the computer. And is there a pointer here? Or? No pointer, okay. So it's about phosphorus, basically.
So for this camera, you have to be here.
Oh, okay. I'm going to have to look at the screen here. I can't see it here. We'll see how it goes. It's what's in sludge, I think, that maybe the focus is today. To talk about phosphorus, so there is a lot of information on this slide, but basically there is a policy within the EU to actively recycle phosphorus from different sources, and one of them is sludge. So it's a finite resource. The EU imports about 90% of the phosphorus it uses. There's only one active mine in Finland, and that feeds mainly the Nordic market. And we put it on the so-called critical raw materials list in 2014, and that took a lot of work with DG Enterprise. 70% of the rock reserves, P-rock reserves in the world are in Morocco. And the prices are very much linked to oil because of the cost of sulfuric acid to refine the phosphorus from rock. And you can see that on the left side, the peak here in 2008, which was caused by very high oil prices, and then and that was like an 800% increase. And then later on, as we can see during recent years, there are things like US places tariffs on pea imports from Morocco and Russia. India increases phosphorus subsidies. China halts fertilizer exports. Turkey halts fertilizer exports. Russia halts fertilizer exports. This causes volatility and food prices go up. All in all, just to say that there's a need to improve the processes and the economic viability of recovered pee, and I think that's basically the main topic here. A little bit about sewage treatment plants, and I've been working with sewage treatment plants since I was a very young researcher in Ottawa, getting sick in downstream of sewage treatment plants while diving and things like that. But they are not originally, and they really still are not designed for nutrient reuse. They're basically designed to clean water and discharge it. And what's left is stuff like sludge for disposal. So originally, the best thing was to remove all the pee, or 90% of it, by using aluminum salts or iron salts. But these compounds in the sludge are not available to plants. So they're very poor. It's not really well designed. Recently, and that's in the last 20, 30 years, is a biological method, and also calcium and magnesium. Things like struvite, which you may have heard of, which are kidney stones, in fact. So there is some improvement in these treatment plants with their capacities for providing a product, a recycled product. But what's in the sludge, and I think that's basically one of the concerns today, from the food that we digest and excrete, we have organic material. It's about 50 to 70% of the dewatered sludge. There's mineral components, up to about 50%. And amongst those, there's a small amount of nitrogen and phosphorus and potassium. And of course, there's bacteria, some good, some bad. And then we have drugs and cosmetics, what's left of those, usually in trace levels. Residuals. Drugs work better if they're persistent, and so they persist right through the whole system, right into the receiving waters. From the clothes we wash, in our washing machines, we produce microplastics. Svensk Vatten, they say about 5 to 10 grams are produced per person per year. That ends up in sludge. And then in the combined systems for all the older cities, including Stockholm, we have drainage water, stormwater as it's called. And that's heavy metals and persistent compounds from different activities, from transport and just basically all the runoff you get from cities. Some nutrients, some organics, some inorganics. So we should be very aware and proud of Svensk Vatten, which has spent decades assessing the levels and the fate of all these contents in water, sludge, and soil, because there has been reuse of sludge in agriculture and other places. So we'll talk a bit more about that. The whole thing really is a discussion around risk assessment. There's a lot of emotion about everything that is in a toilet and that ends up maybe eventually on land. Humans will say yuck. So risk assessment is important, and risk governance is important, and that will help determine what actions can be taken. So there's some take-home messages that we'll come to in a few minutes. As far as the technologies for reuse, so we're talking about direct application of treated sludge on fields with or without upstream cleanup. That is the way it is in most cities across Europe. And the recovery rates of phosphorus are about 60%. Advantages are it's cheap, it's available, it's a catalyst, if you like, to reduce urban pollution, because the cleaner the sludge, the cleaner the society. There are disadvantages, and that's transport costs and some contaminants. We'll talk about those. The other second process is extraction of the nitrogen and phosphorus from wastewater, as well as a sludge. That's like struvite that we spoke about. Calcium or potassium phosphate precipitation. You get higher recoveries of 70 to 90%. Purity is high, it's plant available, farmers like it. Low levels of contaminants. It's expensive, it's not very voluminous. Those are the disadvantages. Third one is heating it up and burning it to ash, so in mono incineration. And then the extraction of P using acid mainly. It's a sterile product. You get 90% recovery. Sterile, it's acceptable to most people, but it's expensive. It burns all the carbon and nitrogen into the atmosphere, and there's heavy metals left over. Fertilizer industry is not sold on it due to heavy metals usually, if you talk to them. And then the last one is pyrolysis, not combustion, but it's a oxygen-free kind of burn to biochar. And that will allow for extraction of P in different ways. That's high, 70-90% recoveries. It's scalable. It's carbon sequestered. It's available to plants. There are some pollutants which are volatilized at those temperatures. It's about 400 degrees. The whole thing about persistent pollutants is not yet studied. So pyrolysis is still, it's not into the church yet, so it's so the situation with sludge disposal, it's a big problem to get rid of it. Like farmers that have animal manure, cities have to get rid of their sludge somewhere to landfills. So the activity across this chart you can see is that on the blue side, dark blue and light blue, it's agriculture and composting. The red one is landfill, and the yellow one is incineration. So we have driving this thing of reuse is that we have a really low level of raw material security in the EU and in Sweden. So 90% of it is imported, as I said. But a few of the countries have high levels of sludge incineration, and they're just burning it and then doing something with the ash, usually landfilling. And some development has occurred about that practice. In Germany, they're actually going to run this campaign so that, and it's because of phosphorus security that's driving this thing, that the reuse of sludge will be banned by 2029. And that's for treatment plants for greater than 100,000 people. And by 2032, for the cities that are 50,000. So that will provide about 85% recovery, and this will replace about almost half, maybe 45% of the P fertilizer they import. Some people say that's a good development. Switzerland says that's a good idea. They're doing the same thing even earlier by 2026. So many other countries are not going that way. Sweden is one. Ireland is an interesting one. It's the one on the extreme left, and you're looking at 80% of the raw sludge that's used on the fields in Ireland. The method that Germany and Switzerland are pushing is mono incineration. You can't put it in a mixed incinerator like in Högdalen here in Stockholm. That would provide a very messy product that can't be used. So you have to have a special incinerator just for this, and you have to remove the heavy metals from the ash, and all of that is a potentially expensive and lock-in technology which will stay the same for the investment period of 30 to 50 years. So there are some good questions about this. Sweden, on the other hand, is taking a different route from basically any country in the whole entire world. And that is to work in a very constructive fashion with all of the potential pollutants and to try to eliminate them at source and to change processes and all that kind of thing. REVAC, which is the program, it's run by Swedish Water, it's taken a lead on this. It's a certification system. It prevents the entry of toxins into the wastewater system, and it allows the municipalities to decide what to do with their sludge. So it results in, and we're up at 50% reuse now. That means the sludge in 50% of the cases in Sweden is acceptable from the point of view of it being, let's say, environment friendly, and it will be potentially not a problem, if you like, for farmers or for society. And there's a lot of discussion about this activity because I don't think it's well understood. There still are many debates going on, and of course the SOU that the Swedish government is running did highlight this data. But so we use about 50%. So that's the story there. The final takeaways is that we have to be more efficient. We have to use less phosphorus, try to get the highest output for manure, for chemical fertilizer, for sludge, no matter what it is. And we have to recycle more. Source separation, very important if we're going to try to do it effectively. Clustering cooperation amongst the private sector, civil society, government, and academia. This will create new markets and new jobs, so this is something good. More informed debates like this one to avoid the lock-in technologies that we spoke about. And basically the whole purpose is cleaning up sludge means we're cleaning up society, because most of the stuff in sludge is coming from our bodies. So I think it's a kind of a mirror of society, and I think that's the last slide. Yes, it is.
Thank you so much. Arno, please stay with me. So from your point of view, you gave this good description of a number of techniques and a number of sort of ways forward. From your personal view, with your experience, which would be the smartest for society?
In terms of extraction, if one is going to extract, it looks like pyrolysis is heading in that direction. I think mono-incineration is probably going to be more expensive than it should be. Struvite is already a standardized extraction method from wastewater, not much from sludge. So that's proven, and it's right across North America. It's in some cities in the EU. But of course, clean sludge should be used primarily. I think that's the easiest one. That way you'll get much more participation across the entire world, I would say. It's a real problem because most of the wastewater is not treated. There is no sludge. It's just running right out across.
Yeah, right. That's the step first, to treat it, of course.
Yeah.
You pointed to Sweden as one example of a country sort of moving ahead. Are other examples from the European perspective in the EU? Are there things happening? We know that the European Commission has come up with this feasibility study now on the sewage slide, so there might be a revision of the directive, probably.
Yeah, the REVAC program is not practiced outside of Sweden. It may be there. I think there is some discussion about it in some places, like in Holland, but and obviously the other Nordic countries as well, because I think we learn from each other. Yep. But no, it's engineers still doing their thing without really taking on a broader, let's say, multifaceted approach, which I think is what REVAC is doing.
Okay. Thank you so far. We'll get back in the discussion. Thank you, Arno. All right, so we will move on. Gert Cornelis, you are a researcher. Gert Cornelis, welcome. You're a researcher at Stockholm, at the University of Agricultural Sciences in Uppsala.
Yep.
And you have been looking at contaminants. You, in this presentation, will be focusing on microplastics and see what happens. Please, the floor is yours.
Thank you, Gun, for that. And it's a first for me. So I'm a soil scientist, but I promised to put in some marine perspectives as well, since this is not a soil breakfast, it's a marine Baltic breakfast, right? after Arno's talk, give you a good picture of what the broader problem of sewage sludge is, and I'm going to only touch on a teeny tiny bit of this discussion, which is microplastics, mainly because microplastics is, well, it's not a new problem. We know about this for some time, but it's something that has emerged only in very recent times, and well, which is also the reason why we know so very little about it. And I'll be focusing mostly on what happens afterwards when once you deposit this sludge on soil. What will happen to the microplastics and where will they go? And is it done with what we know currently? Is it a problem? And so if these are the three things I want you to take home from my talk, giving it to you right away. So if you do add sludge to soils, you are going to increase the microplastic concentration. I mean, this is a given, and currently there's no way around it. But then another question is, yeah, but will the microplastics then actually stay there, or will they increase and increase and accumulate for all eternity? Well, that's a no. The microplastics move, they move down, they move vertically, they move horizontally. And then the final question is, yeah, is that a problem? Should we be worried? And currently, we should not be worried. There is no clear indication that concentration exceed ecotoxic effects with the current information that we have. And there are also no clear indications that they enter the food chain. So, since, yeah, here's my first marine perspective here, because this is where the awareness about the plastic problem and the microplastic problem emerged. You see this poor turtle here, and there are many pictures of turtles being entangled in these are macroplastics, and you've probably also heard about what is called the ocean soup, which are patches in the Pacific here, as you see on the bottom figure, where plastics accumulate, macroplastics that is, and then what are microplastics? Microplastics are smaller particles, smaller than 5 millimeters, and then usually because of physical-chemical processes, they emerge from these macroplastics. So you have microplastics not only in the sea, you find them these days everywhere. I mean, some of you may have read papers of when they found it in the ice in the Antarctic or in the glaciers of Greenland. You find microplastics anywhere. And then also we'll be talking about something which is called nanoplastics. These are even smaller particles, smaller than 1 micrometer. And these are the most problematic ones because we have very little ways to detect them. But I'll be talking about soils, and when soils came, well, it's actually good to be a soil scientist because you first see what the research trends are in water, and then you can start applying for funding for them because eventually they will come down to soil. So it's really a comfortable thing to being a soil scientist. Actually, but when it comes down to plastics, the most prominent contamination pathway is what you see on top there. So plastics are used very much in agriculture, and for good reason, because they conserve water, they avoid the growth of pests, and they also but they are used like in films. In this case, this is a strawberry farm, but you also see the greenhouses on top. The problem is though, once they have served their purpose, they're single use and they need to be removed. But then you see in the middle picture there that they get damaged in the process. Maybe the farm has driven over it with his tractor. They get ripped into pieces, and they are very difficult to get away from the field. Eventually, you can try to tow them off, but then a lot of fragments remain, and it's really you can't really start hand picking them. So what does the farmer do? They just simply plow them in, whatever is left on the field. And then you have certain regions, especially in the south of Europe, where you find really high concentrations of plastics in the soil. Not only in Europe, there's also regions in China, and in China they use PVC. Over here in Europe it's mostly polyethylene, and you find very high concentrations to that extent that you do see actually an effect on yield decline. So there are effects of plastics, especially when you reach these very high concentrations in soils. But This situation, though, when we're talking about Sweden, is not so extremely relevant. You do find these plastics films being used in the south of Sweden, but it's not as extensive as, say, for instance, in Spain or in Italy. So what is the exposure route for plastics here in Sweden? This is, surprise, surprise, it's sludge. And this was a paper in 2016 where there was the alarm was raised that we are maybe disposing all these sludge on soil, we accumulate plastics, and they were raising the alarm. One of them is actually a colleague of mine in SLU, Martin Fitter. And the idea was they did a rough off-the-bench calculation of where the plastic concentrations might end up with, and they came up with very high results. But they were assuming that the plastics would not move. Another thing that they were also assuming is that the plastics would not biodegrade, but this is true for most of the cases. Polyethylene, for instance, is a major plastic that you will find in soils, but also polyesters, because of textiles, and their degradation rates are very low. In the regulatory arena, they have not been waiting for us scientists to produce all the results, and they have already taken action, and I think most of you will probably know many of the things I present here, is that, for instance, Chemicalieinspectionen, they have installed a prohibition of microplastics being used directly in cosmetic products, like toothpaste, for instance, to avoid their release into the environment. The center one, ECHA, has now, well, they have, in some years' time, there will be a prohibition of the use of microplastics in all products. Microplastics as such, that being. The direct implication for soils and agriculture is that, for instance, microplastics used, for instance, seed coatings or slow release pesticides, slow release fertilizers that often are encapsulated in plastics will no longer be allowed. But ECHO does allow an exception for biodegradable plastics. So this is probably where the trend will go. And this is also part of the farm to fork strategy that the EU is implicating. And finally, this report is on the left side is a result of a public investigation that the Swedish government has started up to answer the question, should we now be worried with using sludge on land? And microplastics has been a part of that. And I wanted to share you with this little excerpt, which I wanted to highlight. This particular phrase here, that this public investigation actually reached the conclusion that I will present you also today, is that that there is no negative effects to be expected on the short term, at least. So we went out into the field to see whether microplastics would actually move, and we have at SLU, we're not only in Uppsala, we're in many places in Sweden, and we also have long-term field trials where we added sludge, in this case since 1996. We also have a field in Uppsala where we added sludge since 1956, but I've not been investigated that one. And what we found was that there were significant microplastics down to 40 centimeters. Why is a 40 centimeters important is because that's below the plow depth, because of course the plastics will be mixed in by plowing, but they appear to be moving even further down. And we found even in these layers down to 40 centimeters, even lower, we found rather big fibers of plastics there, as you can see on the pictures. And these were polyethylene, so probably emerging from textiles, so from the sludge, that is. And we think we have a hypothesis that it is mostly because of earthworms. Earthworms digging, they eat the sludge and litter from the top, but also the soil containing the plastics and the sludge. And then they're actually moving it down through, and they make these permanent burrows that you see here. And this is also a X-ray tomography picture where you can really nicely see in the columns that we investigated in the lab. And what we did is we analyzed the microplastics. These were metal-labeled plastics that we could easily detect. And we found them to be present just alongside all these burrows where you see that the earthworms have excreted matter into what we call the drillosphere now. And there's not much in the soil matrix itself. And what does that mean? Well, if water runs through this soil, it will probably go through these burrows. and then maybe take along some of the plastics along. So on top of the bioturbation, mixing the plastics down, you have potentially also water transport. So what's the complete picture in terms of fate? Well, we're talking a lot about sludge here, so sludge emerging from wastewater treatment plant, but there's also in compost also being applied, or biogas residues in Sweden, also an important addition to soil. They all contain plastics, and on top of that there was an investigation in Sweden that also identified traffic-related and artificial grass as a source of plastics to soil. And then bigger plastics, they fragment, and then they are milled down by earthworms, and eventually may end up in runoff or in the sea, in rivers. Then the question whether they actually will reach the sea is still an open one, because there's this the estuarine system that you see here. I mean, you see here this picture on top, and so what naturally happens with clays, for instance, are all particles. So probably also microplastics is they aggregate where there's a saline gradient, because this always actually leads to suspension, and then if they are resuspended from these estuarine systems or not depends on a lot of different things. So we don't really know that yet. So this is my last slide. So the effect levels, they are the high milligrams per kilogram. This is what laboratory experiments. So even percentages. And what we measure in Swedish soils, not only me, but there was also a study from Svensk Vatten, is that it's only a few milligrams per kilogram. Question is, will we ever get to this toxic threshold or not? This still remains to be seen. We're developing models to maybe actually answer that question. But more important than in this model will be what society does with the plastics. And one thing that will increase is that plastic will use more and more plastics. This is a given. But maybe there are biodegradable ones, which will probably relieve some of the problems. And maybe also because part of the REVAC system, if we start looking at microplastics and start sorting them out a little bit better, we will actually reduce our concentration. So there are ways around it. Okay, with that, I thank you for your attention and happy to answer questions.
Thank you so much. So you were sort of touching upon this issue at the end, will there be a situation further on with increased risk? What do you foresee as could happen that would, make the topic even hotter if for soils perspectives?
Well, I think the topic is already rather hot, to be honest. But there's a strong push from the European Union to use biodegradable plastics. And one thing that is being currently investigated, if I mean the producers of, there's big companies like BASF producing these, claiming that they are totally biodegradable in the soil. This remains to be investigated. There's still a lot of discussion around it, and it's and they also seem to generate some toxic effects still. So it's and at the same time they're not as good as the single-use plastics to be used in films, for instance. So that is going to be a major driver, and the other driver is to sort plastics better. I mean, we're using less. Plastics bags have now been prohibited. That sort of basic action actually will help a lot as well.
Thank you. Thank you so far. Arno, please join us and we can continue this discussion. I'll turn this off. Yes. Right. Please step in here a bit. Come closer.
Okay.
Yeah. So far, wonderful, great. And now it's time for questions. Anybody wants to start? Otherwise, I'll go. Here, Charles Barkov, colleague of mine. Yes.
Yeah, Charles Barkov at the Baltic Sea Center. It's a question to Jet. Has anyone looked at the impact of the microplastics on the worms that eat them? Also, as something that might impact or inform the discussion on the Baltic Sea, because when the plastics end up there.
Yeah, yes, people of course have looked at that. We wanted also to look at that because we added microplastics in this experiment that I showed. We added rather high amounts. I mean, we're talking, high milligrams per kilogram. And we thought that we saw a slight effect on avoidance behavior, that they were staying away from the top layer, where most of the microplastics were. It was, we thought visually it looked like they were, but it was not statistically significant. But then there have been other studies, but they used percentages, and they found effects. But the thing is, that's no longer a soil; that's a heap of plastic. So I mean, it's in this in ecotoxicology, it's always the dose does the poison, right? So it's you always have to look at both sides, exposure and dose. And it seems that we also end up in this high milligram per kilogram range, which we do not find in the field, in soils, and I'm pretty sure in sediments then that we do not have those concentrations either.
Any more questions, thoughts? Down there, please.
Thank you very much. Örjan Berlin, Stockholm University. Basic question. You talk about the non-degradable plastics. How long do they last if they're not biodegradable?
Well, that would be well, it varies from plastic to plastic, of course, but I would say hundreds of years. Yeah.
It's a long-term perspective. Yeah, please.
Yeah, I'm Helena Parkman. I'm retired from the Swedish Chemicals Agency, but I have a comment to the first talk. I think it's, I wouldn't call the REVAC system clean sludge. I think it's necessary to point out that the REVAC sludge is not clean from hazardous substances. It's cleaner, but it's not clean.
Okay, yeah, let's go to that question. What is clean? Because it has criteria, but nothing is really clean. Or no? What do you say?
But, I think the objective of REVAC is to produce a sludge that can be reused in our agriculture systems. So it's cleaner. Yeah, you're right about that. So just to be very short about, but the main thing is a big transformation in society, and that is to start to understand our bodies and what excreta we produce, what materials we consume, and all the other materials that we use. That's what this is all about. So a cleaner sludge means a cleaner society, and there's no getting. So if you start looking at epidemiology, and you say, why are people dying of different diseases, cancers, all these sorts of things. What's in the bones? Do we have cadmium in our bones? Does it cause so yeah, cleaner. Yeah.
Okay, we agree about that. Cleaner. Yes, please.
Hello, I'm Göran Nilsson Axberg, formerly SEI. Arno, 15 years ago I heard you tell us that the phosphate issue is as serious as the climate one. So what's your present opinion on that? How can you tell us a little about the geopolitical situation of human excreta? Thank you. How serious is the phosphate supply to food supply in the long run? Thank you.
Now we're moving into Russia, Morocco, and hot issues. Really, I think.
Yeah. No, I mean the Russians have actually so-called clean cadmium-free P-rock. It's magmatic, whereas the Moroccans have sedimentary rock, which is naturally contaminated through because it's sedimentary rock. It's biological accumulation of heavy metals, and cadmium is one. Follows phosphorus, but so it's a global problem because it's finite, and the geopolitics are dicey because there's such a preponderance of the resource in one place. The Americans were very fast off the track in 2010 when we were talking about peak phosphorus. The Americans very quickly set up a free trade agreement with Morocco to monopolize that potential flow. detection of peak phosphorus in 2008, just the awareness of it, created if you like, a major reaction, and that rock phosphorus went up in price by about 8 times in about 3 months. The volatility of it is still there potentially. Right now, it's been reclassified as a lesser problem mainly by the U.S. The EU does not see it as a crisis yet, but obviously it's on the raw materials list. Is it bigger than the climate problem? It's more immediate. It will cause food prices to skyrocket, especially in countries that have no new fertilizer or that are paying very, very high prices. And those are mainly landlocked African countries. There you see that the price of food is just beyond what is affordable.
Yeah, thank you. And this brings us back to sludge, of course, and the usage of that. Now we have somebody there, yes, or is it Lisa first? Maybe from the people watching online.
Yeah, just one question from the web here. Someone's wondering, does stormwater account for a major or a minor contribution of contaminants to sludge in combined systems?
Okay, maybe that's for you, Gert. Major or minor from stormwater?
Stormwater that's actually a very good question, because if there is a very high flux of stormwater, what sewage systems sometimes do is they bypass the whole system, meaning that the water will actually end up without any treatment in rivers, and then, of course, then the microplastic loads do not go via the soil. First, they go straight into the river, to the sediment, and then perhaps also to the seas. And so I would say that indeed is important. And stormwater also, they contain, from roads, for instance, they contain a lot of, especially in Sweden, then rubber microplastics coming, and eventually so that's a major contributor.
Thank you. One more there, yes.
Hi, Maria Mancilla from Stockholm University. Thank you for your presentations. I will have one question for each speaker. So first for Arno. So one of your key take-home messages was to reduce the use of phosphorus. And how do you imagine that happening? So through which kind of policies or which kind of practices? And one question for Geert. You mentioned the accumulation of plastic in Southern Europe and how that has affected crop production, if I understood you correctly. Do you know what has been the reaction? Has it been to rather clean the soil or to add more nutrients or whatever it is? Okay. Thanks.
Let's start with the Southern Europe agriculture. I think that's a shorter answer.
Oh, okay. Yeah, well, I am pretty sure that it has affected yield to some extent. There is currently a bit of a problem there, because they have to get rid of their plastic. If they take it off the field, what they can take off the field, they have to get rid of, and but there is very limited options to recycle that plastic, actually, because it's so dirty. The only thing you basically can do is you can burn it. Before, we used to ship it off to China, but they no longer want to take it. So it's just accumulating there right now. So that's actually a logistical issue that is giving them a pain. There's very little, and there's also a strong drive within the EU to ban the use of single-use plastics altogether in agriculture. So that's going to happen at some point too. So there's a lot of money being invested now from the EU in research into using biodegradable plastics. And there's 2 players in Europe, BASF and an Italian company that are producing these. So I think we're moving probably towards that.
Okay, thank you. And a short answer here, maybe if possible.
Short answer. How to convince farmers to use less P? First, we have to change the nitrates directive from Brussels, which basically allows farmers to put in sensitive areas 170 kilos of N nitrogen per hectare per year. There's no limit on phosphorus. Degraded manure is a way of polluting Baltic, North Sea, all the rivers and lakes. That's what's going on today.
Thank you. Final question, please.
Thank you. Good morning. Excellent presentation, Arno and Gert. My name is Nelson Ekane, a colleague of Arno's at Stockholm Environment Institute. Another increasing concern apart from microplastic is these polyfluorinated carbon compounds, PFAS, which somehow find their way in sludge. And there are concerns about the potential implications for human and environmental health. Could you please share your opinion about this, I mean, from a research point of view, how we can deal with this in short and long term?
Okay, thank you.
Yeah, that's a major problem, and well, our group is investigating fate of PFAS in soils, mostly associated not with sludge deposition though. But you're right, there are PFAS detected in sludge for sure. They are very, and some of them are very mobile and very persistent. So the combination of the worst, basically. It's a big problem because I can't really present you with a solution here. How we are looking into different things, how to get rid of them, but I think it has to start at the source. We have to use, this is my opinion though, we have to use less of these products and find good replacements for them because it's a big issue. I mean, contaminated land, cleaning that up with PFAS with high concentrations, then because now we're talking, of course, not very high concentrations of PFAS when you deposit it on land via sludge. There are very limited solutions there. The only thing that I know is injecting lots of active carbon in the soil.
Right, so we're getting back to clean society again. So a final wrap-up question from me then. If you want to address policymakers, I mean, you have them maybe even in the room today, what do you want them to do tomorrow?
Well, I'm a researcher, so give me more money. No.
No, that's not an allowed answer here.
Yeah, but I think the route that we have taken now with the Green New Deal and farm-to-fork strategy is the right one to really investigate biodegradable plastics is, I think, the way to go because we cannot do without plastics in agriculture, but we cannot do with lots and lots of plastics in our soils either.
Right, thank you. Arno.
Yeah, it's a complex question. I think ideally it would be to put, let's say, excreta from humans on the psychological map and to change society. You don't do that through legislation. You do it through, this sort of thing. A transformation of society that changes waste into a resource, and that will affect many cycles, the whole circularity question.
Thank you so much. A warm hand to our researchers. And thanks to all of you who have participated or online or either here. The next Baltic Breakfast will be in May 29th, and we're going to talk about recreational fisheries. So please welcome back then. Thanks for today.